Hi guys, you're welcome to this class. In this class, you're going to be looking at reinforcement learning. Reinforcement learning is one of those aspects of machine learning. Oftentimes, when we categorize machine learning into its various aspects, we talk about supervised learning, we talk about the unsupervised learning, we talk about the self-supervised learning, and then we talk about the reinforcement learning. So on this reinforcement learning series, it's going to be a series of lectures. Here we are going to be looking at what reinforcement learning is. We are going to be implementing the concept of reinforcement learning from theory to code. And this is going to be the first series of such lecture. So you can join me as we proceed. Just as I have said, we can categorize the branches of machine learning into various categories. Here we will have the supervised learning. The unsupervised learning. The self-supervised learning. And then the reinforcements. So in this series, like I have said, we are going to be focusing on reinforcement learning. So what is reinforcement learning? So reinforcement learning, you look at the situation where when you take an action, you get a reward. And by getting a reward, you learn to take better of such actions, more to get more rewards. What does that mean? So what that means is I'm going to be giving a series of examples to be able to explain this. One of such example is for a student who is in a class or who is going to school. You know that when you go to class, you pay attention to what the lecturer or what the teacher teaches. You read your books, you do your assignments. Oftentimes, you get more reward, and that reward is you score better at your exams. You get more marks at the end of the lecture. I mean, at the end of the session or the semester, you pass better at those courses. So, because you know that by taking such actions, by reading your books, by doing your assignment, by listening attentively in lectures, by doing everything necessary you need to do, okay, you get small reward. You score better at those courses. As a result of such, you would want to read more. Okay, you want to apply such principles to other courses you take as well. So that is the principle of action that begets reward. And for such actions that begets reward, you will want to, on maybe when you have other lectures, when you apply these principles to a course and you realize that you got an A, from that course, you definitely want to apply the same principle to other courses. Perhaps you could also get an A in these courses because you just apply this principle and you've seen the results or you've gotten the reward. So that exactly is what the principle of action and reward is. But in reinforcement learning, we describe this in using series of examples or using series of um, you know, elements that exist within this particular description. Oh, what do I mean? So I'm going to describe a loop. A loop where we have a state. Okay, we do have a state, and within that state is something we call an agent. Okay, and then we also have something called an environment. Okay, we have the action. Oh, sorry, we have the state, the agent, the environment. Now, between the agent and the environment, we have a reward, right? And then also between the agent and the environment, oh, sorry, we have an action, not a reward there. We have an action. Yeah, and then between the agent and the environment, the action determines the reward. Okay, so, and by getting the reward, determines which state you have. I want to give an example at this point. The example I want to describe here is a dog. I believe many of us, knows dogs. Dogs are domestic animals, and they are described to be one of the friendliest animals to humans. So let's assume you do have a dog, and you are trying to imbibe some characters or some behaviors in your dog. And one of them is when your dog sees you, you want your dog to always sit. How do you imbibe such character in this dog, or how do you train your dog to do this? I'm not a dog expert, but I'm going to give an example of what that could look like. So, how that could look like is to reward your dog with maybe a freebie, maybe something to eat when your dog sits. So when your dog sees you, you command your dog to sit, and when your dog sits, you reward your dog. So when you do that often and often and often, you could have a dog that always wants to sit when he sees you, because he knows when the dog sits, he gets a reward. In this example, the dog is going to be referred to as the agent. The dog is going to be referred to as the agent. The dog will be referred to as the agent, while the environment where the dog is, the particular environment where the dog is, maybe within your compound or within its cage, or whichever way the dog is. So such kind of place where the communication between you and the dog and the reward is where we are going to call the environment. Okay? So the action, okay, sorry, the state where the dog is. So perhaps before the dog sits, the dog was probably, running towards you, or the dog was just walking around the compound, or the dog was just doing something. Okay? So the dog is going to be in a particular state. Let's say, for example, initially the dog was just, walking. That is the initial state the dog is. So we say walking is the initial state. Walking is the initial state. And then the dog, by sighting you, because the dog sees you, and it has learned to always sit when it sees you. So by sighting you, the dog decides to sit. So it's transitioned from walking to sitting, which is the new state. Now, by transitioning from walking to sitting, then by sitting it gets a reward, right? So by taking this, by transitioning from walking to sitting, we say the dog has taken an action, because truly it has taken an action. It was in a previous position and it decides to take an action by sitting, and by sitting it gets a reward, of the pebble. So we'll say, each of these position it was from walking to sitting is defined as the state. Defined as the state where the dog is. And the decision to transition between one state and the other state is known as the action. And the action begets a reward. The action begets a reward. And that is exactly how reinforcement learning works. You have an agent that is in a particular state within an environment and transitions a state to the other, which is going to be known to be an action, and such action begets a reward. And that reward can either be positive or negative reward. So we can have a positive or negative reward. So when the dog, sits, it gets a positive reward of maybe a food or a freebie that it eats. But when it does opposite to that, perhaps it's barking at you or is doing something, you don't want, they get a negative reward. Maybe it doesn't get a food for that day. Or maybe, you have a way, there's something that is done, right? So that could be the negative reward. So by defining each of these, I'm going to say a state. A state is what the agent currently sees. Okay, so that is a state. Then we have an action as well. So an action is what the agent, decides to do. Then also we have a reward. So, and by that reward, we talk about the score the environment give back. So what does the environment give back? So, the environment, could be the person who is handling the dog, could be the environment where the dog is. And what does the environment give back when the agent takes an action? What does the owner of the dog, or what do you give back to the dog when the dog decides to take an action? So that is the reward. Then also we have a policy. You have a policy. So a policy is the rule the agent uses to pick actions. So by the time this dog has, been able to practice this action over time, to be able to, see its owner, transition for whatever state it is to the other state, which is what we call the action, and this action begets a reward. It will have learned this with time. Over time that it has learned this, it's going to become a policy. So what is a policy? So a policy is the rule the agent uses to pick actions. The rule the agent uses to pick an action is what we are going to be referring to as the policy. So we've talked about the example of the dog. Now, so there are also important concepts that we need to understand, when it comes to deep learning, to deep reinforcement learning. So one of these is the reward or the return. So the return is the most important thing that we are going to be learning. Is one of those important things you are going to be learning in reinforcement learning, because this return determines the overall reward that the agent gets, uh, throughout its episodes. So which you are going to I understand that. Okay, well, I've talked about episode now, and you really have not explained that. So I'm going to explain that as well as I proceed. But let's talk about the return. So what is this return? So the return has a particular formula which is called G. So you say G equals R0 plus R1 plus R2 plus dot 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 to Rn, right? Now, so what we do with the return is that, so in return, we believe the assumption with return is to say future rewards should matter less than immediate ones. A reward 100 steps away, right, is uncertain, and then we discount it. So what does that mean is that we are going to be having multiple iterations for this reinforcement learning to be able to learn a particular policy. Okay, so for the dog to be able to know that it has to sit before it gets a food, and then whenever it does not sit, it doesn't get a food, or it gets a negative reward, maybe beating, or maybe it doesn't eat, or something like that. Beating is going to be a maltreatment of animal rights, but maybe there are other things that we do to the dog for it to be able to learn that policy by maybe not giving it food. Okay, so it's going to learn this through multiple iterations. So each of these iterations is what we refer to as episodes. So an episode is an iteration where an agent decides an action that begets a reward. So that's an episode. So where the dog sees you, it sits, or you decide not to sit, and it gets a reward, or it gets a reward, positive or negative. So that particular loop is what we refer to as an episode. So we will have multiple episodes for the agent to be able to learn a particular policy. Now, when each of these episodes begets a reward, each begets a reward. So at the end of the day, after we've trained this agent to be able to perform a particular action that gets a reward. So in each of these episodes, you are going to be getting a reward. And that reward is what referred to as RO, R1, R2, up to RN, depending on the number of episodes, right? So when we sum up all of these rewards, we have something we call a return. So a return is the sum of all possible rewards obtained throughout the episodes, right? And in this reward, we are going to be discounting future rewards, okay? In return, we discount future reward for current reward. So we prefer reward that is obtained now than reward that is obtained 100 steps away. So meaning, like every human being, for example, um, many human beings, for example, if you are told to get a particular, let's say you are told to take an action and you get $100 now, compared to taking that same action and getting $5,000 after a year. Many people could prefer to get the $100 now than to get the $5,000 after a year. So that's the reason why, we always want to get the reward now rather than wait, for the reward. And, that principle is what we are going to be applying to the reward here as well. So prefer to get the reward now than to get it in the future. So what that means is we are discounting the reward that is obtainable in the future for what is obtainable now. And to express that mathematically, we are going to say reward G equals R naught or R0 plus gamma R1 plus gamma squared R2 plus gamma to 3 R3 plus gamma to 4 R4 plus right? Yeah, so what does gamma means? So gamma is a number between 0 and 1, which is referred to as the discount. Is the discount factor. Gamma is a discount factor of future rewards. It ranges between 0 and 1, right? Okay, so that is basically that about that. So oftentimes, well, depending on the situation, oftentimes you want to pick a very lesser discount factor, or you want to pick something closer to 1. So let's say, for example, a discount factor gamma equals 0.99, right? So let's say a discount factor is 0.99. And then in time step 0, so we want to calculate our total reward now, G, at time step 0, time step 0, a reward equals +1. So let's say when the dog does what it's supposed to do, right, it gets a +1 reward. When it does what it's not supposed to do, it gets a -1 reward, or a -100 reward, right? We penalize it heavily when it does what it's not supposed to do. And then when it does what it's supposed to do, we give it +1. So now at time step 0, it gets, or the first episode, it gets a reward of +1. At step 1, also get a reward of +1. At step 2, get a reward of +1 as well. Then maybe at step 3, then it probably does what it isn't supposed to do. Then it's penalized heavily, it gets a reward of -100. So what that means is if it has taken 100 steps correctly, and then it takes a step that it's not supposed to take. So the past 100 step, has been cancelled by the step it takes. So it knows that it's taking it's being penalized heavily for whatever action that it's not supposed to take when it takes it. Okay. So to calculate the total reward G, all right. Now we are going to be using this formula to calculate the return, right? So here we are going to be saying RO, which is 1 plus gamma R1 0.99 times 1 plus gamma squared R2 0.99 squared times 1 plus 0.99 to the power of 3 times -100. Right? So for this, you're going to say 1 plus 0.99 plus 0.98 plus -97. So at the end, what we have is -94. We have approximately -94. The G is approximately less. So that's basically the reward, that we get at the end. And what you realize with this is that, the crash at the end destroys the entire episode. Okay, and that's the reason why the agent, must always think ahead and not just take the next step. Okay, so that's basically that. Now we are going to go into code to be able to see, how this is being implemented. Okay, before going into code, I think there's an important thing I need to explain. So someone might want to ask, why is a gamma less than 1? Why is a gamma less than 1? So now, one thing you're going to realize from this is, if our gamma is equal to 1, if gamma, which is the discount factor, is equal to 1, what that means is the future reward is actually the same thing as what is obtainable now. And because we want to discount future reward for what is obtainable now, so we are going to be having less than 1, so that for future reward, we are discounting it. We are expecting less of it compared to what we have now. So, and that's the reason why it has to be less than 1. So when it's equals to 1, it means future reward is actually, same as what we have now. So when it is 0, so what that means is that only the next reward matters, right? Only the next reward. Only the next reward we are obtaining after this first time step is what matters. Because if this is 0, then you just cancel everything. Every future reward is 0. And then you are just picking on what is obtainable after this uh, what is obtainable now. So, and we are not just focusing on what's obtainable now. We're also interested in future reward, but we are just discounting it. Okay, so having something that is less than one and not zero is a sweet spot of our discount factor. So that's the reason why we choose such values for our discount factor. For example, in this case, we chose 0.99. So let's go into code. So here I'm going to create a notebook. Now, in this session, what we are going to be using, we are going to be using a Python library called Gymnasium. So I'm going to import that. We're going to use NumPy as well. We have Matplotlib for visualization. So here I'm going to import the required libraries. Okay, so now that that has been installed, so we're going to be making use of those libraries. So the first thing you're going to do is you're going to create an environment. Okay, so here is the environment you're going to be using. Um, So instead of this, I'm going to have a for loop. So we are going to define the number of episode as well. Don't forget I talked about episode. And decide to use 10 episodes. Then in each of these episodes, we are going to create an empty list where we store the rewards we get. So here is an example of what we are going to be looking at. So in this, you are going to see that we've created an environment, which is CartPole. Is one of these examples we have within the gym environment. So you're going to be running 10 episodes. We've created an empty list to have all of our rewards across each episode. So here we have reset the environments. You initialize the environment you are going to be using. Total rewards is 0. So, we are going to be increasing that as we proceed. Done is false. So this is going to change to true when we are done. We are picking a random sample here. So while not done, we're not done yet. So when we are done, we are going to be getting that from the environment. So we're going to be picking a random action, the random action in the environment. And then here, what we are doing here is we are getting, so for the action we take, we are going to be getting the reward, the observation, if we are done, and truncated, right? So truncated is if it crashes. So we are going to be getting all of that, from the random steps we take. So from each steps, it determines all of these things. Just as I've explained about the dog earlier, then don't forget that we've initialized our total rewards to 0 here. So whatever reward we get, we increase it. We increase the total reward by it. Then once you are done, if it's truncated, that is if the agent crashes, in the environment. So we or if it's penalized, if it is penalized, so it breaks. So that's basically that. And then so we append our total reward and we print what we get in each episode. Then once we are done, we close the environment and then we print the total reward. So that's basically that. So now we are going to run this. So let's see what we get. Oh, okay. Hmm. So it seems there's a dependency we need to install as well. Okay. Oh, okay. So you can see the cat pole, right? You can see the cat pole. Now for each of the episodes, so you can see at episode 1, the reward gotten was 27. At episode 2, 19, and so on and so forth. And at episode 10, what we got was 15. So you can see the reward, obtainable across each of the episodes, right? So that's basically that. So that's basically that. So now we are getting this random rewards, this random rewards here. So what we want to do now is, so what we want to do is to be able to visualize this reward, to be able to visualize the reward. So that's what we are going to be doing next. Okay, so what we are going to do now is you're going to create a function. We're going to define a function. So within the function, we're going to add this episode as an argument. So return this as a return value. Mm, yes. Okay. Mhm. Okay, so that's basically that. Now, the next thing we are going to be doing is uh, the next thing we are going to be doing is you are going to visualize this. So define a function to visualize this. Right. What so determines this? So we resize the graph we are going to be. What's in figure? Okay. 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 So here is what we have with this. Uh, so once you are done with this, then you can now call each of these functions. So the first thing is don't forget you're returning all rewards here. So say rewards equals run random agent. And here, since number of episodes, n episodes, episodes equals 10, right? So that gives us number of that gives us all the reward obtainable through those 10 episodes. And then we are going to be using that for visualizing agents. So here we are going to print something and let's say it's run random run agents with random. Actually, don't forget I mentioned so we are using random actions. Yeah. Once you are done with that, I want to visualize this. Right. agents roles. Then how you do that is to say plots agent password. Okay, so I think that's all here. Okay, so now let's take a look at this. So you can see this is the cat pole, trying to balance itself. Uh, okay, so here is the here is the graph showing the reward obtainable across each episode. So you can see since the highest amount of episode gotten was at episode 10. So um these are just random rewards, and this is just to show how agents works, how reinforcement learning works. The agent decide to pick an action and get a reward within the environment, and learn that over time becomes a policy, and we're able to also get the total return, which I think we are going to be looking at in the next classes. So I hope you understand everything I've explained so far. So if you do, kindly like, subscribe, and share this video. And see you again in the next series. Bye for now.